So getting the most with Desmos, using technology in geometry with statistics and Algebra 1, and of course, examination program. I'm Lorraine Jackman. I'm Secondary Math Education Associate.
And hello, my name is Lori Washington. I am Education Associate in Test Development. And I developed the SE Ready Math 60 rate and the Algebra 1 EOCEP test.
I'm Janelle Mills, and I'm the High School Education Associate in the Office of Standards.
And Janelle is co-piloting today. Okay, so from the legal department, we have a disclaimer on the use of artificial intelligence. The content presented is the intellectual property of the South Carolina Department of Education, SCDE. By participating in this event, attendees agree they will not record, capture, or share its contents without permission. Attendees agree they will not use artificial intelligence, AI, to capture or summarize the contents of the event. The SCDE reserves the right to remove attendees using these services. Okay, and we're done with the legal part. We are happy to announce that you will get 1 hour of recertification requirements. You must attend the webinar live and be an active participant. You must remain in attendance for the duration of the webinar. And at the end, you must complete the feedback form at the end. And if you complete all 3, you will receive a certificate. So take a moment to look at these reciprocal expectations. These are the things that I will provide to you. But I want you to choose one that will be your focus today. And if you choose to, you can share what will be your focus today. You can put that in the growth mindset. My focus today will be having a listening ear and ensure that others feel valued. And actively engage and participate. Okay. All right. Thank you for sharing and for being brave. So let's take a look at this quote. Technology is just a tool. In terms of getting the kids working together and motivating them, the teacher is the most important. Bill Gates. So how does technology factor in a math class? Do you agree with this quote? Few responses. Technology is not something we should totally rely on. Modeling, talking, practicing is important. Okay, we have agree. Engagement goes beyond using a computer. We have to allow for student to teacher and student to student engagement. Oh, agreed. But as an old teacher, you're not allowed to call yourself names like that. I'm still learning, and sometimes from the kids. That is so true. A few years ago, when our district became one-to-one, we did have a parent who was from a different generation. He was an older parent, and he was not comfortable with technology at all. And I tried to explain to him that your child will need to use technology to complete some of the math assignments. And he said, I'm not going to have that internet in my house. So I gave him an example. I said, years ago, everyone cooked outside. They were afraid that if they cooked inside the house, that they would burn the house down. Fortunately, that did not happen. So they were able to harness and use that technology appropriately because it was a necessity. So today we will discuss how to use technology, specifically Desmos in geometry with statistics, and how to use it appropriately. It is not meant to replace the hands-on concrete math manipulatives, but to enhance what is being taught in the classroom. So thanks for sharing, everyone. So our learning intentions and agenda all combined. Together, we will learn how to use the Desmos geometry tools in geometry with statistics and Desmos graphing tool in GS and Algebra 1, and also the Desmos testing calculator for Algebra 1 EOCEP. So before we begin, how would you define success for you? Take a moment to complete the sentence frame. This session will allow me to put it in the chat, but do not press enter until I say, hey, the session will increase the usage, geometry in class, Desmos and geometry. Okay. All right. Yes, we're going to learn more about the tools today. There are lots of tools. We're going to focus on a few of them. All right, so let's begin. Hopefully everyone is on a computer, but I know sometimes you may have to connect through your phone, so you may have to look at this later. But if you are on your computer, open a new tab to desmos.com, and you may also see the link in the chat. Okay, thank you, Janelle. All right, so when you open that, you're going to get to this page, and you're going to see lots of tools. We have the graphing tool, the scientific tool, four-function matrix, geometry, and the 3D tool. So right now, we're going to be using the geometry tool. I want you to click on that. When you get to the geometry tool, you're going to see a blank page like this. So if you go to the upper right-hand side, you're going to see a wrench. Click on the wrench, and we want to add a grid and axes. Okay, so do that now. Once you have that, we're going to create a polygon. And it doesn't have to match my polygon. Any polygon that you want in any quadrant that you want. And when you create your polygon, just make sure wherever you started, that's where you go back to end it so that you can deselect that tool. So I'm creating my polygon. Okay. Now you don't have to do this now, but just want to show you, you can label your vertices. So once you select the vertex, a menu will pop up. You'll see the label. And it will automatically start at A, but you can change it to whatever letter that you need to. And if I select the polygon, I can also change the color. So once I select that, another menu will pop up and I can change the color. Okay. So we're going to apply rigid transformation to this polygon. So I do hope everyone has their polygon. If you look at the top for the, on the top of your webinar, you can see the React button. You can click that to let me know, or just give me a thumbs up in the chat. And we're good. Okay. All right, thank you. So we have our polygon selected. So now we're going to go to our transformation tools. And the first one that pops up is translate. So click translate. When you click on translate, it will give you a prompt. Choose the start point or a vector. And then once you choose your start point, then you will choose your endpoint. Once you select the endpoint, it will immediately translate it for you. So that's what mine looks like. So our next rigid transformation, and because I already have the one that I translated first selected, that's going to be the one that we're going to reflect. But you could go back to the original and reflect that if you wanted to. Okay, so I have reflection. It asked me to choose a line of reflection. I could create my own line, or in this case, there are multiple lines of reflection that are on the polygon, so I just clicked one of them. And let's change the color. All right.
I have a question in the chat, Lorraine.
Okay.
How did you get the transformation tool?
How did I get the transformation tool? So if you look right at the top here, once I created my polygon, once I click on it, you'll see it looks like a compass. You see that, and that's the transformation tool. So the next one that we're going to do, and please remember, this is being recorded, so you will be able to go back and look at this later. So we're going to rotate. And just like before, when you choose the transformation, it gives you a prompt. Choose a point of center. So you can choose any point of center that you want. And in this case, I chose the origin 0, 0. But it doesn't have to be there. Once you choose your point of center, then you get another prompt. Construct or choose an angle. And I chose 180 degrees. And once I say go, it will automatically rotate for me. Yes, you can reflect over the axes. So you will see later, because these are screen recordings that I did. You will see later that you can construct your own line segment, or depending on where you want to do it. So yes, you can. All right, so far we have used the geometry tool to use for our rigid transformation. So we translated, we reflected, and we rotated. So we have two indicators in geometry, MGSR 2.1. In summary, we describe the results of the transformations, or 2.1. And in 3.2, we demonstrate congruency of triangles and quadrilaterals with a combination of rigid transformations. So here's an example from Math Nation Unit 8 for MGSR 1.3. So we have polygon KMNP is the image of polygon ABCD after a sequence of transformations as shown. Describe a sequence of rigid motions that takes ABCD onto K, M, and P. And then I just added, demonstrate your solution using Desmos. So I'll give you a minute. How would you describe a sequence of rigid motions that would take ABCD to K, M, and P? And feel free to add that in the chat. There are multiple ways that this can be done, so don't be shy. Okay, reflect and translate. Okay, rotation over x equal 1, and then translate up 4 units. Great. Okay. And then now you can have your students demonstrate how to do that. So what I did here, I recreated these two polygons, and then this is one solution. So as you can see, there are multiple solutions to this. So what I did, I first translated vertically. And then for this, I created my own line segment. Because I wanted to use that as my line of reflection. And then I reflected. So first I had to create the line segment, and then I reflected. And then you can have your students do this. Okay, so that was one way to use the tools. All right, so now let's look at MGSR 7.1 and MGSR 7.2. So 7.1, we're going to use angle and segment relationships in circles to solve mathematical and real-world situations. And 7.2, we're going to investigate and apply relationships in circles, inscribed angles, radii, secants, and chords among inscribed angles, central angles, and circumscribed angles, and between radii and tangents to circles. That was a mouthful, but it covers a lot. So one of the ways that you could use this is directly from Savas, topic 10. And this is the corollary to the inscribed angle theorem. So if two inscribed angles that intercept the same arc are congruent, so let's take a look at that. So I have angle RSU and angle RTU, and they intercept at the same arc RU. So what could we conclude here? We can conclude that angle S is congruent to angle T. But let's prove it. Is that actually true? So we can use one of the tools here to measure the angles. So we're going to be using the angle measurement tool in Desmos to do that. So once you select that tool, you will highlight your angle, and it will automatically give you the measurement. So this measures 28.3. And based on the theorem, angle T should also have the same measurement. So let's see if we do. So now we have angle RTU. And we do have the same measurement. But there's more. Instead of your students drawing this out manually, can we prove that this is true no matter what size the arc is? So we can continue. And we can start moving around the arc length. And as you notice, that the angles are still congruent no matter how wide it is because they intercept at the same arc. Okay, so that was the geometry tool. That's just a little taste. And now you're going to be able to use the graphing tool. Yes, I love that comment that this is awesome for our next unit. Yes, because you know what? I am still a visual learner, so I have to see it to believe it. So just reading it is not enough. I actually have to see it. And this will save you so much time with the students. Okay, so this is what I want you to do. We're now going to be using the graphing tool. So we're going to go back to that main page, and then you're going to click the graphing tool, and I'll give you a minute to open that up. All right. So once you have your graphing tool open, you're going to notice that it already gives you a grid with the axes there. Okay, all set. Thank you. All right. Wait, we're going to be creating a table. And the easiest way to do that, just type in the word table. And you have a table. There are other ways too. You can go under the menu section here and click on that. But for interest of time, I want you to just type in table. So you're going to have your table ready because you're going to be going into a breakout room in less than a minute. So once you create your table, you can add the numbers, just like you would in any Excel spreadsheet. And you're actually going to be creating this exact table. You'll have an opportunity. I'm speeding this up for you just a little bit. When you do complete the table, I just want to point this out. There's a little tool on the side, and this is your regression tool. So you're going to be using that to answer the question that you will have in the breakout room. So you'll click that, and you will have your linear regression. There are more than that are available, but we're going to be focusing on linear regression. All right, so let us look at these are the two indicators that we're going to be looking at. And even though they are in two different courses, they're quite similar. So DIPSR 1.2 in geometry use two representative points from the data to find an approximate line of fit and compare it to the line of best fit. So this is what you're going to be doing. And then find a linear function for a scatter plot that suggests a linear association. And that one is in Algebra 1, DIPSR 1.3. So this is what you're going to be doing. All right. So in 1 second, you're going to get the link for the breakout room. And when you get there, I want you to create the table in Desmos. So you're going to choose somebody who will create the table, and then you can have someone else find the approximate line of fit from 2 points. Once you've done that, you're going to find the line of best fit using the regression tool. That won't take very long. And then I want you to compare the two lines. Put a screenshot of what you've created in this box, okay? That this is what you're going to do. So we're going to compare your approximate line of fit to the line of best fit. And we can have one person that you designate from your group to put their reaction, whether or not their approximate line of fit actually matched the line of best fit. So when you created your line of fit from the 2 points, so if it's a yes, click the heart. And if it's a no, well, you can click that "oh no" face. And the reactions, yeah. Thank you, Ms. McCree. Okay. So would you be able to use this in the classroom? How would you be able to use that? You can put your response in the chat. And I will take 1 or 2 because we're going to be going into the next part that I know that you're waiting for. Yeah, so you're comparing your lines of best fit with hand-drawn versus Desmos. Okay. When you clicked the linear regression, you can see that you have more than linear regression. You have a whole lot of regressions that are there. And then you could have selected the equation to be on its own separate line. Okay. All right. On to the next part.
All righty. Thank you, Lorraine. That was awesome. It's a lot of new tools that can assist learning in the classroom. This next segment is about the Algebra 1 EOCEP test. And I know you're thinking this is just in the nick of time for testing season coming up. Again, I'm Lori Washington, and in assessment, I developed the Algebra 1 EOCEP test. And I wanted to take some time and go over Desmos as it relates to the end of course test. And so all of the information that I'm going to go through can be found on the assessment quick links for teachers page. If someone can put that link in the chat. So what we're going to do is look at the Desmos testing calculator. And we're going to work with that within the online tools training. And we're going to talk about some restrictions that it has and things of that nature. My goal today is that everyone, no matter your experience level, because some of you are coming in, you might know stuff about Desmos and the testing calculator. You've been doing this for years. So hopefully, no matter your experience level, I want everyone to walk away with at least one new idea or strategy or something to add to your toolbox. This next slide is actually on our page. It's the calculator requirements. And actually on this calculator requirements page, it talks about like the Desmos calculator and all of the different calculators that you can use on the test. However, our focus is on the Desmos calculator. So South Carolina has a testing version of the Desmos calculator. And if you look here in that second paragraph, it talks about using Desmos and Desmos.com. You guys have just been there. However, in red, there is a link to the South Carolina testing version of the calculator. So here is where you're going to find the calculator that's on the test with the restrictions from the test. Okay. On this testing calculator, some functions, they are disabled. And it's not a mistake. It is something that here at the state, South Carolina, it is curated. It is specific to what we wanted it to have. So it's a South Carolina modified testing version of the test. All right, and I see a question about, is this the embedded, this is embedded in the test. So I'm going to go to another screen. I'm going to answer your question. From our quick links page, that I was just showing you the calculator requirements and that link that you got. So you got here. All right, so if you can see this part, here you see something that says South Carolina PDF, and then you see these calculators. Okay, we're going to go there in a minute. So if you click on South Carolina PDF, and you might want to bookmark that, that gives you all of the restrictions that are on the calculator for the test. So here it says South Carolina Desmos calculators are available on SC Ready and EOCEP assessments. So what you want to do, you come down here, you say, okay, well, I'm teaching Algebra 1. So on Algebra 1, it's telling you that their assessment has the scientific calculator and the graphing calculator. And then you say, well, okay, I want to know about this graphing calculator. So you'll come over here and it says, well, you know what, those images and folders and notes, although on the standard calculator, they're available, not on the testing calculator. They're not available when they take the test. So this gives you all of the restrictions and what's disabled on the test. So this is important for you to have and for you to know. So this is something you might want to bookmark, and then you'll look every year to make sure you get the updated version. So this is for this school year. Okay, so that's the South Carolina PDF. So I wanted to make sure you guys saw that. All right, I'm going to go back to that first page. And let's say you want to take a look over here at the graphing calculator. You see here the subversion. You want to click on that. So that is the calculator. And someone asked later the same calculator with the same restrictions. This is a separate link. So you can use this in addition to the OTT. You may use this separate link where it says South Carolina version, and you can use this with your classes so that they can get used to using the testing version of Desmos. Okay, so it functions just like the one that is embedded. All right, and you notice it says South Carolina version, and you notice the bar is, it's green. It's a little different from the other ones. So that's how you can tell that it's the testing version with those same restrictions and things of that nature. So it's going to be good that your students practice with that so they'll know what they have access to and what they don't have access to when they actually take the EOCEP test. Okay. All right, so we're going to go into the online tools training. All right, so for the online tools training, you're going to want to open this up in Google Chrome. And you're going to want to go to that quick links for teachers page and scroll down to where you see online tools training. And I'm going to just call that the OTT because that's what we normally call it. Okay, so you're going to have to use Google Chrome and go into the OTT. All right, and once you click on that link, you're going to click on EOCEP, online tools training, and click on Algebra 1. And then you want to click on the standard version for us to go into the online tools training. So the online tools training is really just for the tools purposes, getting used to using the testing platform and using the tools that are located within the test. So as I'm going over how we're using Desmos, or I'm just kind of modeling what a student might do on Desmos, I may talk about some of the other tools as well that's on the online tools training. That's so that the students, so that you can know what you can point out to the students and be familiar with that platform. Okay, now I am in the online tools training. I'm going to show a quick video here. And what I'm going to do is do a problem, and it's the problem that you actually just did. All right. Because you might notice that, some of the questions, you've done these questions, there's not many questions or whatever the case is, but I think the point is you might want to use your own questions and then maybe have the students work within the online tools training platform just so that they can get used to the test. All right, so this particular problem, if you notice, this is going to be like the same problem that you were working with Lorraine with. And we're going to take a look at linear regressions. This is PAFR for 1 or PAFR for 1. And the students are asked here to find that correlation coefficient, find that line of best fit. Okay. All right. And so here you might say, well, the students, they can just use that linear regression tool. So let's say you have a problem that's not in the OTT. You can just have the students pull up Desmos within the OTT, and that way they can get familiar with that platform. Okay. So that's what I've done here. So if you take a look at the first part is the table. Now, before Lorraine said that you can type in table, and the students can still do that. They can type in table, or they can click on that little plus sign. And with that, you might see that there's only 2 options. Okay, they can type in a table and they can type in a function. And that's it on the test. Okay, so let's say they have a problem where they have some data points, and they're just going to get those data points in there. As they type in those data points, it will populate on the graph. And here I'm just showing putting in that last point, 9 and 38, I believe is what it is. And so there I'm showing that there's something missing. Okay, so if you just saw that, there's not the same things on all of the calculators, right? So there was something missing. All right, the students might be used to having this problem already done with the graph, the regression tool, but that linear regression icon is not on that test. It's not on the test. So there's some work that they're going to have to do. Okay, so there's no regression icon there in that left corner. So the students will have to know the format for the template to input here, and they need to know how to interpret those variables once they put that in. So I'm going to show how that is done. So here, students would need to type in Y, sun, the little tilde symbol. And there is a lag. It's going way too fast for me. I'm gonna stop here. So I'm not sure if you can see here, you see the Y sub 1, the little tilde symbol. And they can use that keyboard to type those things in. And this is just their slope intercept form. And they're doing y equals mx plus b. The y sub 1 and x sub 1 is specific to this table. So it's important that if they have more than one table in Desmos, they would need to make sure that they specify which table. So that is specific to that table. Okay. And once you type that in there, the calculator, and this is how it has been in the past, before Desmos did that update, this is how the students would put in the regression. And if you notice, there's some information down here. So you know how we talk about students using technology as a tool. It's not going to give them the answers. These are conversations that you have in the classroom so students can understand, like, what are they looking at? What does that mean? That correlation coefficient, it's there. However, this is something that they would need practice with in the classroom in order to be able to explain what that is. Because remember, in Algebra 1, they're not calculating that correlation coefficient. They just need to be able to use technology in order to find that and be able to interpret that and know what that means. Okay, so they're going to have to know what they can use. There's their R, and understand what that is, what they don't need, right? And understand what those variables mean. Okay. So here I showed using the Zoom Fit so you can see exactly what you're working with. Okay. And then you can minimize the input section and take a look at that line of best fit there with that regression. Okay, so that was the linear regression on the Desmos testing calculator. Okay, and notice this problem is not in the OTT. So I just use this kind of like as an overlay, and you can use your own problem and have students work within the OTT. Those are some of the like suggestions, like in data review, where teachers said that they do things like that. They have their own practice problems and have students work within the OTT so they can practice. Okay. All right. So the next one is actually on the OTT. It's question number 8. And I'm just going to kind of work through some of the tools and work through how model like how a student might solve or work through this problem if they, had this. And this is coming from, and I call it PAFR. I make names up for everything. I think we all kind of say that, but this is PAFR 2.3. And we want to take a look at the tools, the graphing calculator, and the help button. I want to make sure I bring that up before I round things out. So here, this is actually, this is a still shot. So I'm gonna have to switch my screen. So, all right, so here it says, in the OTT practice hint number 1, use a graphing tool to help represent the problem. So here we have, it says, which function has a minimum at -2 and a line of symmetry at x is equal to 3. And they give you like 4 functions, and the students have to look at that and figure out what they're talking about. So hopefully they'll know exactly what they're talking about, and they would know that they could use some of their tools here. So a student here might decide to highlight some important information in the problem. And this is just me going through the tools. Okay, and there's other videos that can help with learning the tools and things of that nature. Okay, but it is important that students know where to find these things. Okay, the masking tool is good. All right, so here we're going to start with the highlighter. They're just highlighting some information. A student might do something like that. I'm just getting some lag here. That's just all right. So the notes, the students, if they can't have their own notes, but if they have it in their brain, they can type in whatever notes they want on particular problems, and those notes will save when they go on from problem to problem. So they might just say, the minimum is the lowest, max highest, something like that. All right. So even though they have the calculator here to help them, they still have to know how to interpret everything. So they still need to know what they're doing. So like we said, the technology is just a tool. Okay, so I don't know how to get rid of that bottom part, but I really wanted to show. So, all right, so it's going on, but I really wanted to point out they can type in these equations as they are. They can type in the equations in any kind of form. They can use standard form. They can, the next example, I'm just going to type in the negative 2x squared plus 12x. They can use the keyboard on Desmos, or they can use their own keyboard. So I've done it all different ways on the video. Okay. If you notice that equation, that first one was in red, and I think I showed here where you can toggle that graph on and off. Okay. So let's say a student wanted to type in all of the equations that are on the answer choices. Let's say they did that. So I'm just going to zoom on by because of the time. All right. Yeah. All right. So they typed in some of the equations, and each one is coming up in a different color. And like I said, if they click on the color, they can toggle that on and off. They can get rid of the equations if they want to. So here they might say, well, I want to know where negative 2 is on the graph. You can type in a point. So typing in 0, negative 2. This wasn't really necessary for this problem, but I just wanted to show you that. But let's say they wanted to find 0, negative 2 and, you know, find the minimum there or something like that. Okay, so they might look here and say, well, okay, I already know if my minimum's negative 2, then I know what the answer is not going to be, because the other one has like a maximum at negative 2. So they might take that off and unselect that. And they might even come over here on the OTT or in the testing platform. There's a cross off tool, and they can eliminate those choices. Okay, so they're doing that with the cross off tool. So this is just modeling how a student might work through the problem. So they're left with 2 choices. Okay, so they might say, well, okay, the rest of the problem, and if you notice, we can move that graphing calculator around to look at the rest of the problem. And they say, well, I want to graph x equals 3 to see where that is. That's supposed to be the line of symmetry for my answer choice. So they did that and found that it was the line of symmetry for that last answer choice and not the other one. So they crossed that C out, and then they were able to select their correct answer, what they thought was correct. Okay, and then they tried to click on it. It didn't work, and they had to unselect cross off, then do the pointer to select that answer choice. Okay, all right, so this is just an example of what it could be. The last part here, the help button, that is available on the test. Now, the practice hints, no, that's not available on the test, but the help button is available. So students can use the help button to give them some information about the calculator. And the information on the calculator, I said the notes will save, but once you get rid of that calculator, let's say you click the X here, that information is gone. Okay, so it doesn't save that from problem to problem. Okay, so hopefully that was helpful to you. Lorraine, if you could get control for the next slide.
Yes, ma'am.
Yeah, so hopefully that was helpful to you, just kind of navigating modeling how a student might work through the problem. The online assessment tutorial, this is right in that same section with the online tools training. There's a video that kind of gives more information on like the tools. It's there's a voiceover and they're talking about all the tools on the test. So please make sure that you expose your students to this and not just tell them to, go look at it, but you work with them and make sure they understand like where to find these things, because there's really a lot available. They just have to understand like how to use them. And they, of course, will need to have background knowledge on what to do for the test. All right, so hopefully you found something, gained something out of this little section here about the Algebra 1 EOCEP and the use of the Desmos testing calculator. Do make sure you use that OTT in the classroom, and also know that you can use that testing calculator using that link with the same restrictions. You have access to that as well. So thank you. And Lorraine, you can take it away.
Okay. All right. So did we achieve success? You can put this in the chat. I used to think, and now I think. Put that in the chat quickly. So today, hopefully, did you learn how to use the geometry tools? You learn how to use the graphing tools, and also learn how to use the testing calculator for Algebra 1 EOCEP, all in Desmos. So remember, in order to get your recertification credit, you just need to fill out this attendance and feedback form, which you'll be getting in 1 minute. We do have some upcoming opportunities, so we're going to be putting those links in the chat. Lori, you may have to do that, I think, maybe, if you can. Okay, thank you, Janelle. And also, we do have some assessment committee opportunities, and we're going to put that also in the chat.
Yes, we have committees coming up in the summer, data review, content review, reviewing the new test items. So please make sure you apply for the Algebra 1 committees, or if you're in 6 through 8, you can apply for those as well. We always need teachers and need that feedback from you.
We do. Okay, so we thank you so much for giving up some of your time. I know how much it is to spend extra time at the end of your day, but we would like for you to complete the feedback survey. We do look at the feedback, and that will help us to plan more professional learning opportunities such as these for you. And that link should be in the chat right now. Okay, great. And as soon as you're finished with that, you may leave. Thank you so much for participating today.